Okay, well, everybody's getting settled. I'm just going to do a quick introduction. My name's Kevin Lang. If for those who don't know me, I'm in the Department of Veterinary and Biomedical Sciences, but I'm on the Collegiate Research Committee. And today, for Ethics Week, we chose today to do the inaugural event for our collegiate seminar series that we're starting here, called the RIDE Seminar Series. Stands for Research, Innovation, Discovery, and Education. We're really interested in capturing and showing everybody here the breadth of research that's going on in this college. I'll talk a little bit about it at the end, but just keep an eye out for emails. We're going to be doing an event, a seminar every month on the second Wednesday of every month from here on out. So I'll talk a little bit about that at the end. Right now, I'm just going to hand it over to our MC for the day, Peter.
That's right. Thank you, Kevin. I think we're good, right? Folks, can you hear me in Zoom? Okay. My name is Peter Larsen. I am assistant professor in the Department of Veterinary and Biomedical Sciences. I'm also co-director for the Minnesota Center for Prion Research and Outreach. But it's my capacity as chair of the CVM Research Committee that I'm here to serve as moderator for this exciting event. I'd like to thank the entire CVM Research Committee and the Office of Associate Dean for Research, especially the Interim Associate Dean of Research, Dr. Alonzo Guedes, as well as Adrienne Burns, Jessica Knight, and Shannon Casperson for making this event possible. So this is the Annual Research Ethics Week. This is our contribution to Annual Research Ethics Weeks for the university. And we have a very important, timely discussion on the intersection of artificial intelligence with higher education and scientific research. We are standing at the cusp of a remarkable technological revolution. AI's integration into our educational and research practices presents unparalleled opportunities and challenges. Today, we aim to explore the profound ways AI can enhance learning and scientific discovery while also critically examining the ethical, privacy, and practical concerns associated with its deployment. Approximately 50% of the introduction I just read is generated by ChatGPT. So the usage of AI across many sectors of our society, including higher education, this part was written by me, I swear, it's growing by the day. We must be asking ourselves how much of what we hear and see on a daily basis is either influenced by or entirely the product of AI. So we have a fantastic panel for you today. I will now introduce our panelists and then we will begin with questions. This is very much an interactive discussion for everyone here in person, for all the folks on Zoom. Please be thinking of questions. I want the majority of questions to be coming from the audience, so please participate. We do not have a microphone for the folks here, so please just, it's a smallish room, say your question loud, I'll repeat it, and we'll pass it off to the committee. Okay, without further ado, introducing our committee. We have Dr. Joseph Konstan. Dr. Konstan is Distinguished McKnight Professor of Computer Science and Engineering, and he is the College of Science and Engineering's Associate Dean for Research. His research focuses on social and human-centered computing with a particular focus on recommender systems, the AI-based personalization systems that drive the selection of products, videos, news, and other content in online sites. Dr. Konstan's key focus is on ensuring that we have human-centric and human-relevant metrics and research methods for evaluating the impacts of different algorithm interface and data set choices on human users. And we'll hold our applause to the end of the panelists' introductions. Manci Lee. Manci Lee is a PhD candidate in the Comparative Molecular Biosciences program here at the CVM. He has spearheaded a variety of important research areas in chronic wasting disease, work that has led to significant translational discoveries and several provisional patents. Manci has also pioneered important new research on neuropeptide-related mechanisms in the pathophysiology of Alzheimer's disease, and she is currently using AI to discover which neuropeptides may be associated with the development of Alzheimer's. She's also researching how to leverage AI to enhance technologies for protein biomarker detection in a variety of neurodegenerative diseases. Dr. Jonah Cullen. Dr. Cullen is a USDA postdoctoral fellow at the University of Minnesota, working for Dr. Molly McHugh. Jonah's research interests are centered around bioinformatics, exploring areas of microRNA expression, pangenomics, and developing pipelines for managing the high-throughput sequence data. Jonah uses AI, like ChatGPT, as learning tools primarily for code debugging and optimization, understanding complex coding concepts, and brainstorming computational strategies. Dr. Gerard Cramer. Dr. Cramer has spent his whole life finding ways to work with dairy cows. Prior to joining the University of Minnesota in 2013, Gerard spent time running a dairy farm, owning a foot health specific veterinary practice, and getting both Doctor of Veterinary Medicine and Doctor of Veterinary Science degrees from the University of Guelph. Dr. Cramer now splits his time between educating veterinarian graduate students and performing foot health related research. He is using AI to improve the welfare of dairy cows by evaluating AI-based technology for detecting lameness at an earlier stage. Essentially, and these are his words, he likes cows, working with data, and running trails. Drew Swartz. Drew earned his bachelor's degree in animal sciences from the University of Missouri and his master's here at the University of Minnesota. In the fall of 2022, Drew began his PhD under the guidance of Dr. Cramer. His current research focuses on using AI-based technology for detecting lame cattle. And finally, ChatGPT. ChatGPT is our final panelist, is interfaced with Shannon Casperson. Of course, most of us are aware that ChatGPT is an advanced language model created by OpenAI. It serves as a versatile tool for natural language understanding, text completion, and creative content generation. Please join me in welcoming the entire panel. Okay, we'll go ahead and start with our first question. And I'm just looking for who's got the microphone. Okay, good. So first question for the panelists. You go first, Jonah. And if you want, you can pass it down and we can just start at this in here. What do you see as the biggest advantage or benefit to using AI in your research? What specific discoveries have you made that you wouldn't have been able to make without AI?
So this is a tricky question for me because much of what I build are AI systems. But most of the time I have not used AI in the construction of those systems. And I think I'm going to mostly answer why not, rather than try to make up a good answer to your question, which is I think AI is phenomenal at taking large amounts of data, munging them around and coming up with something that just might be insightful and maybe even might be true. It's a lot like having a fleet of, 8th graders doing research projects, right? If you ask an 8th grader to do a research project, they dig into the first thing they find in the library, they find an answer, they write it down, and they don't necessarily understand how to tell, was it credible? Was there backing to it? Will it stand up to further scrutiny? And so a lot of what I'm looking at right now is this question of how do we get to that next step? How do we explain the answers and understand where they came from? Or how do we train people to get past that first intuition of, I asked Google, how many cats are there in Minnesota? I got a number.
Right.
It must be right. And turn that into, well, maybe it is right. Where did that data come from? Can you go back to the source? Is it a source that's credible? And that becomes even more true as you get to more complex synthetic things that move forward. So, one way of putting this is in research, AI is phenomenal for coming up with hypotheses and maybe even vetting hypotheses, but it's not the step yet that allows us to go from a hypothesis to a finding and to knowledge. And so I still have a lot of things that we do manually because we want to know we control every step of the way and that no step along the way is one that we don't understand how it works.
Proceed with caution.
Absolutely.
Manci.
Thank you. I think for me, I am a graduate student and I'm from a biological background, so I'm a biologist. And for AI, for me, it's just, I think of it as a tool. And I like to use it with understanding of or control of the biological understanding of what's happening behind that. So I think the most useful part of AI for me is simplifying and accelerating work that's repetitive and involves a lot of calculations. So I think a lot of the people here actually already use AI in this capacity yourself. So the principal component analysis that we use in all the dimension reduction and cell typing in single cell RNA sequencing, as well as the base calling in nanopore sequencing, they're all AI models. So they're already integrated into research in a very useful way. So I would say it's definitely useful. And I can't imagine trying to do dimension reduction by hand with RNA sequencing data.
Okay.
And I think for myself specifically, I've utilized predictability and specifically the feature selection of AI models that provide where I can understand biology more. So for example, I have a whole bunch of neuropeptides I'm interested in. And the question comes up, which one of them are more important than others? And it's kind of hard for me to do that based on the data that I'm getting in this particular data set I've did the differential gene expression analysis on. So I should go to another data set that I find and then use the predictability and the feature selection to help me find what neuropeptides are more important than others that's more applicable to another data set that's unrelated to the original one.
So iterative processes. Yeah.
Yeah, so as a graduate student,
Hold it close to
post,
your mouth, Jonah.
as a graduate
Sorry.
student, you don't have to hear my voice. And
Here you
hear
go.
it.
No, someone
Yeah, I
just wrote
can't
in the
help that.
chat. It's not you, I promise.
Actually, I can't help that. So as a graduate student and a postdoc, I really have like practical application of like ChatGPT, for example, of like code debugging or trying to do complicated things or like really like base level coding languages fast, stuff that I don't want to waste an hour on, where I can ask ChatGPT to help me write it in 2 minutes or whatever. But with the stuff that you were talking about, like how do we get, is that the right answer? The 8th graders in a book, like I don't know. And one of the things that I often see when just reading about where these models are going is like the people that should be using ChatGPT or using ChatGPT to ask coding questions are the precise people that don't need to be asking ChatGPT, right? It's stuff that you could figure out, just takes longer. So it's really, for me, productivity, I think you said that too, is a lot of increase in productivity, getting things working faster. So that's how
Right.
I'm really using boots on the ground.
Gerard.
So kind of the same thing. We use it, or I use it for productivity, like you said, for code and stuff like that. And then for the research we're doing with it, we're actually working in the field. So there's a technology being marketed in the field, and our job is to evaluate it to see if it's useful. And I like the analogy of being 8th graders because it makes a lot of stuff up, and you're looking at the data going, is this real or not real? So I like to say, I don't consider it a tool yet. We have a toy that's sometimes right and sometimes useful, but it's not a tool yet, right? We need people to make it a tool. That's kind of what for the technology we're evaluating.
Right. True.
Yeah, and then kind of going off of that, what Gerard just said is like, we have this cool toy that we're using, and it's kind of coming down to it where we're kind of like, it seems like it has the potential to do this, it has the potential to do that, but then one of the things about it is what we're trying to get it to do is what it's not designed to do. So we're trying to take what it's used for, so scoring cows, and now we're trying to use it for something else that's not quite the same thing, but just trying to build off of it.
Shannon, I don't know if ChatGPT, if you bothered what its most important discovery has been. That's fine. I have questions from the audience. Opportunity for the audience to ask a question. Okay, we're still warming up. Oh, we got one here. Nikki.
So I think a lot about the way that the public perceives artificial intelligence and the way that artificial intelligence is discussed in the media. And I was wondering if you could comment on, like with clients, for example, in a clinical setting or stakeholders research, how you talk about, like artificial intelligence is a little bit ambitious of a name, even the difference between, is machine learning AI, is just large language models like ChatGPT, is that AI? Just wondering how you frame that for.
So yeah, the question is the AI, machine learning that gets covered increasingly more in pop culture, media. How do how does the public interpret that? And for those of us that are using AI in research and clinical practice, et cetera, how do you communicate to the public about using that?
So for me, or for us, basically the question my clients have, or the people I work with, the firms I work with, is will it make them money, right? Can they use it to reduce their cost so they have to pay for it? And then will it make them money? So they don't really care what the technology is or how it gets there. The question they want to know, does it work and make it accurate? And does it reduce their costs, basically? So they honestly don't care about technology. They're intrigued. Like the farms we're working with are probably all like early adopters. So they're interested and intrigued by it. But ultimately for them, it boils down to, will it make them money? Will it help their cows?
I mean, I always just think it's funny, or I mean, when I hear people talking about it in the news and media, we're like, oh, it got it wrong. Oh, look what it did. It got it wrong. We're like, it's not really how it works. It's just grabbing a bunch of databases and stringing all the words together and seeing what have they seen before, but it's not something you can actually get it wrong. It's not.
I think it's also really important to start with what kind of examples are people thinking of? So you take an example like a self-driving car. And if you ask, will it ever be perfect? The answer is no. Will it ever be better than most people driving on the road today? Pretty close now. You know, will it be better than some of my relatives? It was better before they programmed. I know, but
Hey, yeah.
I mean, I think that there is some degree to which people want to understand this, and at a base level, there's a whole lot of very different systems here. But the ones people keep asking about are systems that take in lots and lots of observations and then somehow build a model that tries to generalize over that and apply it to what's next. And in some areas, that's really good, right? Give me 1 billion images, some of which have a picture of a dog in it, and label the dog. And most of the time, I'll be able to tell you whether there's a dog in the next image. Not all the time, but most of the time. Facial recognition has gotten to be really good, except in the cases where you don't have enough data. And so what do we see? Facial recognition systems trained at research universities and companies in the US do a pretty darn good job on white male faces because that's what they were built for, because we were the ones building them and training them on our own faces. And they don't necessarily do a good job on faces that are different. And I think that to me is the big thing to try to explain, that when you do this, it doesn't matter if it's an AI system or a person. If you give a person too few examples of a case and they try to generalize, they'll often get it wrong. If you give an artificial brain skewed data, it's going to come back with skewed results.
Right.
The main challenge is that most of our AI systems, unlike people, have not yet had a mechanism where you can examine what they're thinking and help them understand why they're wrong and how to learn from their mistakes effectively, other than by just loading in more and more examples of data. And so right now people reason better. But that's where I probably would tend to start. There are a lot of AI systems out there that it's probably a good idea to trust your life with today. The autopilot in the airplane you're in does a great job. You know, the auto braking, all of these, they're doing a very good job. But as you get to systems outside the context where they have enough data to do what they're doing reliably, they just get worse. And in almost every case, they didn't know they got worse, and they can't tell you, I don't know. They just do the best they can, which might be wrong.
One thing that I picked up in these answers is probably likely that folks don't understand how embedded AI, machine learning algorithms are already in society, right? And we're just seeing AI a lot in the news, but it's been embedded for a little while, right? Question from Zoom. You have a mic there.
Okay, this is a question from Zoom. What is the difference between a human reviewing data analysis and AI? In my experience, reviewing the data and discussing with other researchers is what AI is missing.
So the human interaction. That's a great question.
I'll just take a random battle on you guys. I'll just take it because I do data analysis and I
Hold the mic close.
Oh, okay. So I'll just take it because I do data analysis and I use machine learning specifically in research that I do. And I always discuss data with my colleagues. There hasn't been a time where I'm like, okay, I trust this model prediction so much, I'm not going to talk to my colleagues. So I always share data analysis with my colleagues, but I don't know. But again, I can only speak from a graduate student and a research perspective.
Great.
Yeah, I think when it comes to the data analysis part of like using AI, you can tell ChatGPT what you want. You can tell the outcome you have in the variables, and it's going to make a suggestion for you. But I don't really think it's out there like actually evaluating the data and then seeing like designing it and or when it's actually making like which model it should choose. I don't think it's actually characterizing which like distributions of the variables or anything like that. So like which model is actually the right one to run. And then I don't think that I think you can train it to, like, I think if you tell it's like, oh, let's put age in there. So, I mean, what age could be like a continuous variable, or you could have it like as a categorical or if you have it like by intervals. I don't think it's able to recognize that. I've been seeing some things on LinkedIn about like a ChatGPT for data analysis, but even then, I don't think it's fully understands. I don't think it's going to be able to fully understand how to actually like set up the models, because there's like a lot of extra options when you're choosing models and stuff in like R or Stata. And then I don't think it actually I don't think it would know right off the bat on how, like which ones to choose and like which families of like distributions and stuff to use.
What is ChatGPT is saying something? Oh. The main difference is that human reviewers can engage in collaborative data analysis and discussions with other researchers, a capacity currently lacking in AI. Well, of course. But go ahead.
I just
Gerard.
add one thing to that. I think at least the stuff we're working with, the technology doesn't it doesn't know how to say, I don't know, or I need more data, right? So we have, like I just dealt with at the center farm, and half the data was wrong because it was making stuff up. I couldn't get a complete image of the cow, and it said, oh, this is what's happening. And then we start looking at it, I'm like, this data doesn't make any sense. And the company's like, no, the technology is right. And then they eventually did enough digging because we kept pushing, and they're like, oh, the image is half cut off because the wall, like the camera's positioned wrong. And the AI just said, oh, I'll just make that up and make it work. Instead of saying, I don't have enough data, this is a wrong image. Whereas a human would say, I can't score this cow, right? So it doesn't. Yeah, exactly. Whereas we could say, okay, I can't score this cow. And the technology says, oh, I can make something up. I think this is going to happen. So I think that's the difference between human like working with data and AI working with it, at least in my experience.
It's going to be really interesting to see how AI interfaces with human creativity. Some of the best eureka moments that I've had, or other colleagues have had, have been at a restaurant, drawing on a napkin, or in one case, it was in the stairwell of a parking garage, just talking to a colleague, and you have these eureka moments, right? And I think AI will help bring us closer to more eureka moments, but it obviously isn't a replacement for human creativity. Tom.
Let's back at some of the major discoveries in important applications. I was thinking when you were talking about when ELISA was used in diagnostics, sensitivity. Oh, then we had AIDS come along, and we to testing for by itself, and it was pretty problematic because we had a positive, not a false positive. That was a death threat. Because, the answer was backup. Very way that's the right. So my question to you, the idea that there are people in the audience that may want to be what's maybe one or two suggestions? What would be a backup? What is your recommendation?
Right.
Valid, repeatable,
Right. So this gets back to the proceed with caution statement. Yep. I'll read it. So the question is, proceed with caution. What, for those of us in the audience online that are interested in AI, that want to use the AI for their research purposes, what's the safety mechanism? How do you check the results? How do you go about that logically?
Well, just from like a coding perspective, we can have what are called like unit tests, right? You just have like checks in there. You have little bits. Every time you change your code, you run it through and make sure things are working as expected based on like subsets of the data. You can't do principal components by hand, right? But you can have little tiny bits and you can figure out what is expected to happen with real data. And you have these tests to check, is this code that I've just dumped into the middle of my code base going to work the way I expect it? Or is it going to mess everything up? That's a very practical approach.
Parsing, yeah.
In the examples you talked about earlier, if you're talking about mental health, physical health, in the early days, we thought the check was simply, well, then you want a skilled professional, a doctor who layers an opinion on top of that. And a lot of the deployments of that turned out to be pretty bad. That in many cases, the AI system would outperform the medical staff that would override it. And the medical staff didn't know what to do to actually determine whether to trust the AI system or not. And so I think a big part of what we need is a rubric, and it's going to be different for different domains, of what is it that you're checking to validate these results and whether there's reason to believe them. In some cases, it's easy. You know, you say, oh, I predict this chemical will have these properties. Great, let's test it. Does it have those properties? You get the answer. But in other cases, something like a diagnosis, what you may need to come back with is, okay, I need to examine the data that went into the system. Does it have enough data that covers the situations involved in this case to believe that it can actually generalize with some reliability over that? Do I have a history of track records of similar cases? What percentage of them have been correct? And I think one of the fundamental challenges we're having is that we're not yet, with few exceptions, well trained in how to use these tools and how to second guess them. And I think that if I were going to take one message to take away from all of this, AI is amazingly powerful, but we have to change how we interact with AI and with its artifacts if we're going to make it as powerful as we want. And, you know, some of that might be changing how we interact with each other. I mean, it's a really silly thing for me to write a 4-bullet prompt to ChatGPT, to have it write a recommendation letter for a student, for it to send to somebody else who reads that recommendation letter, who then tries to extract what I was saying. And maybe we have to throw all of that away and I just send the 4 bullets and everybody understands that that's all there was that was in those 3 pages. I wrote 3 pages because everyone knew if you didn't write 3 pages, you weren't putting in enough effort. But now it's not any effort. So just listen to
Right.
my bullets.
Yeah.
And I think there are going to be things like that that we have to do so that we compress down what we're doing to the essential content and not so much of the fluff that AI systems turn out to be really good at.
So safety mechanisms, yeah.
I think so to kind of build on your point about like how do we use the technology? For us, like the safety was the data. 2 things for me is especially in our example, right? If the cow is a score of being lame today, she should have been lame yesterday or the next day, right? So if it's not doing that, that's one safety check. And then what we did is, okay, we put it in basically a randomized clinical trial saying, okay, because we don't know what we use to compare to normally as humans, and we suck at it. So how are we going to be better than the AI? So then we said, okay, well, if it really is working, then the technology should change the outcome for the animal. So I make the technology makes a diagnosis. We intervene, we do a treatment, and we treat some of the cows and we don't treat some of the other cows. And then in the long term, that should change the outcome of the cow if the technology is working. So then we use what we call normal methods to test the AI technology. Okay, that's the safety valves before we deploy it out in the field. Yes, exactly.
It was a different type of validation you said. I want to follow up on this because it was important that, you know, it was brought up like how AI may be being used in medical clinical settings. There's a lot of excitement about that, but there's also a lot of fear. And so a question that we had was, you know, can AI help bridge the gap in the application of research and veterinary services in underserved areas? What infrastructure is needed to support this? So thinking about, you know, maybe rural communities, underserved areas that may not have had access to some of the technology, right? But they, you know, AI opens the door to, you know, increases access. So how can we leverage that, and what do we need to be concerned about there? So AI in rural or underserved areas.
Well, I can start before Drew can say something. I think the rural broadband is a big deal,
Rural
right?
broadband, yeah.
Just having that access, because some of the farms we work with, they don't even have that. Like, they don't have a reliable enough internet connection to use some of the technology that's coming out there. So one of the first checks they do is like, do you have consistent internet? What's your uptime? And stuff like that. So the farms, or even like underserved communities that don't have access to internet, how are they going to use the technology, even though it might be hugely beneficial for them? Not having them, the technology, like not even having what we consider in the cities here normal, that's
Right.
a starting point.
Right.
And then I think it's like more of a farm thing rather than like a rural underserved area. But then like if we have this technology and has the ability to detect things or let you know of issues that are on the farm, but if it's going to take a lot of time to actually get to it, then like, is it useful if like, I don't know, for dairy producers, they only have so many hours in a day, they're working all day, and then now they have to come over and use this one technology for this, and that's going to take 2 hours, like run some code on it, and now they have another technology for something else. So I think like if it's not really efficient, then maybe not. But then, yeah, I guess from like the vet side, I'm not a vet, so I can't really answer. But then I guess if the technology itself can make a diagnosis or something, but then like, I don't know, you could like telehealth a vet, maybe. I don't know how that would work, but I don't see it replacing surgery or anything.
Not yet, anyway. Others are from ChatGPT, Shannon?
The podium has a mic,
Yay.
which is not helpful for a panel. But let me just share my screen. I asked ChatGPT on my other computer here and it gave me a narrative. So I was like, okay, just kidding, do this in 3 sentences instead. And that's what it came up with. AI has the potential to narrow the gap in applying research to veterinary services in underserved areas by facilitating remote diagnostics and data-driven decision-making. And the longer answer was talking about, let me just see here. They were saying at least about like remote diagnostics and telemedicine, that AI powering those systems is going to be important. So it gave 4 main bullet points when I didn't say do it in 3 sentences. And then it like way too simple when I said do it in 3. So
Diagnostics is a common theme, and you know, it's alluding to infrastructure, right? So infrastructure, just being able to get to the point where such communities can use AI. Other questions from the?
Let me just throw one more thing
yeah.
on this. We're doing a lot of this thinking about the data and what can we do with the data. And certainly putting massive sensors in rural areas will enable not the people who are living there working the farms today, but enable the researchers here and elsewhere to figure things out that change practice for the future. But the other side of it is the actuation. And you said, well, I don't think it's going to replace surgery. There are people working very actively, both for humans and for non-humans, on the question of what medical procedures are routine and simple enough that the right way to deliver them to a place that doesn't have a skilled vet or a skilled doctor is to send the robot and have the robot actually carry out that routine procedure. And, you know, that is an immense amount of AI. That's vision, that's sensing, that's all of that stuff built together. But it's a lot closer to reality than you might think. That, you know, we have people at the university doing all sorts of robot surgery examples that are remarkably promising. The ethics of when do you actually do that for real?
Right.
Big question. But the technology is really close.
Yep.
Inherently biased. And then we're generating data off of that answer from AI that is from inherently biased data, and then we're producing more biases. So how do we break that loop so that we're not just kind of ingraining this systemic bias? I'm thinking of like, you know, outcomes for people of color in medicine and things like that. So how do we make sure that we're not just further ingraining those biases into the AI?
Great questions.
You're not going to like this answer, but at the top level, you simply can't. It's not just that human biases went into the data. It's that data is available unevenly. You can do a lot. You can decide we're going to train separate models over the underrepresented population so that at least we're not trying to treat people on a model that doesn't fit them. That can do a lot. But at the end of the day, if you have a population that is small and a population that is large, the law of large numbers is that the large population is going to get better models that are more accurate. Being aware of that's the first step. Within our society, I think there is a step that we can take, which is gathering data from outside our society. Because the populations that are underrepresented in Minnesota or in the US are not necessarily equally underrepresented around the world. And so doing the work to gather data worldwide when that's what's needed and when it's applicable is another space that you can have here. But awareness and dealing with it is the fundamental thing, because the reality of data is if you have more of it, you're going to do a better job.
I think I want to add, maybe unrelated to that specific question, but I think the first step of models, if in the research, biological research context, is data collection. And that's where study design and hypothesis formation play an important role in that data collection step in the first place, to try to at least try your best. It's never impossible to eliminate everything, but it's, do your best to to collect the data that's unbiased. And specifically for the research that we're doing, we're trying to come up with data selection, and we need to start with a data set that we know that have known positives and known negatives and stuff like that.
Addressing it up front. Another comment? Oh, another question from Kent Reed. Kent's hand went up.
Yeah, you alluded to it a little bit, but I'd like to hear you comment on what you think about the use and role of generative AI in scientific communication.
So scientific communication.
So I think it's a great tool, but I think we have to teach people how to do it. I've reviewed paper, like first drafts of people, and you're like, I know this is not yours, right? Which I use ChatGPT, right? So it's just, how do we use the tool that we have, right? I think it's unrealistic to expect people not to use it because it's a tool, right? It's something we can use. So we have to teach people how to use it and how to check the stuff, right? Because we've had examples where okay, this is the points, these are the references, and then make this into a paragraph. And what comes out is all the things are there, right? But the references are completely wrong, right? So it's how do we use the tool? How do we check the data? But I think we're kidding ourselves if we can say, okay, scientific publications cannot use it, because how do we enforce that? Right. So I think it's finding a way to, how do we use the tool and how do we use it ethically, responsibly? And how do we teach, I think from our perspective, how do we teach people to do that is where we need to go to. So I'm a big fan of, like, I'd rather have my students use it and, okay, let's talk about how you're using it.
Right.
We're all learning. I don't know how to use it.
And I just had a question on that as I go back. And as far as I know, and maybe you know more, someone else does, but as last time I checked, there's only a couple publishing groups are like have specifically outlawed the use of ChatGPT, like Nature Publishing and. Sorry. Okay, so following with.
I was going to get to that, what they've actually restricted. So I would agree that the idea of helping people learn to write by having them start and having something edit and having them edit back, I think that's phenomenal. I think we have to train people to start at the right place. And starting at the right place is almost always outlines and bullets and not something horribly written that it looks like it's full paragraphs, and we can do that. The ethical concerns that have come up on the other side of this, particularly around reviewing, have been huge.
Yeah.
But if you look at what those ethical concerns are, they break down into two categories. What almost everybody's worried about: the National Institutes of Health, the National Science Foundation, American Chemical Society, Association for Computing Machinery, Nature Science, they've all said one of the things that's a big deal is if you load somebody's paper into a generative AI tool in order to help you review it, you don't know where that content is going and whether it will violate the confidentiality that was your obligation. That problem will go away as more of us are in organizations that have strict licenses over these tools that protect the data that we put in them, right? That's a problem because we're using free tools and free tools are paid for by contributing data. But there's lots of organizations that have arrangements to have a ChatGPT that never lets the data go back out. And then you have the second issue, which is, can you trust what came out of it? You don't want to reject a paper because ChatGPT found something somewhere that said, oh, that's not true, that somebody wrote on a web page that was not credible. And so I think the huge issue that's the same whether you're an author or whether you're a reviewer is we need that step that says before you put your name on this thing, you actually have to go through it and make sure that you stand behind it. And we need people being held accountable for the cases where they turned something in their name that a tool wrote that they were wrong. And we're seeing the first examples of that in commerce. Some of you probably saw the example from, I think it was Air Canada, where the chat bot promised that if this person bought the fare, they could get the credit back later. And they said, that's not our policy. Well, if your chat bot said it, you've got to pay.
All right.
And if we start moving to that level where if your review is unethical, you're brought up for charges, maybe you'll be really careful what you take from the tool and how you incorporate it into what you send back. But I completely agree. It's inevitable that these tools will be a useful part of the process. We just need to make sure at the end of the day, there's a human that's accountable.
So,
Yeah, you can answer that better than I can, I'm sure, but I said a question about, so, I mean, how many, at least at the time, like the Nature Publishing Group and Science, they were like, if you use ChatGPT, acknowledge it, put it in the bottom that says, I used generative AI to write part of this manuscript. And to me, immediately I'm like, who is going to put that in their paper? This day and age, no one is going to put that in there.
we're seeing that.
Oh, there you go. All right. So maybe I'm wrong. This,
Yeah.
okay, that's great. At the time,
Well, this gets at the heart of the matter. Like, AI as a tool, ChatGPT as a tool that can use to improve things versus this feels really uncomfortable that we're even doing this.
Yeah.
And
it's not-
so that adjustment period.
And it's not fair either. I'm sitting here talking about using it for code. If it's in my code base and I'm publishing the paper using that, like how am I to,
Right,
how am I
exactly.
to be like, well, I didn't use it to write the actual discussion, so why do I
Yep.
have to reference it? But
Yeah, this is really interesting because all of this is coming to fruition at a time when it's really hard to find reviewers for the peer review process. Like it is tough. Associate editors are having a really difficult time. So at the same time, these AI tools are coming about. It's also the same time when folks in academia feel like they have zero time, right? Post-pandemic problems. And so, it's just sort of this perfect storm that's happening, right? And how do we enter that and how do we come out of it?
And to bring this back to the plagiarism issue, yes, of course, AI tools can result in substantial plagiarism, but let's remember why, right? Consuming lots of content and remembering it leads to plagiarism, right? This is what we hear in the music industry all the time. When somebody comes back and sues somebody because, well, the melody line in your song was clearly stolen from my song. I don't think it was clearly stolen. I'd heard 1,000 songs and I put them together in my head and I but it might very well have been copied. And I think what we're seeing in AI right now is more on the explicit end. And it's largely because these systems have not been programmed with academic standards built in. You could imagine trying to build those standards in that says, if you're going to say something, it needs a reference if it's something that you got from a single source. Now, what are our rules about when is something common knowledge? If I got it from 3 sources, do I not have to annotate it? If I got it from a textbook, do I not have to annotate it? I mean, it's a hard thing. It's hard to teach students where plagiarism begins and ends. We have no idea how to teach AI that yet, but it might be one of the things we have to do.
it's also just like, just in general, not even away from AI, but like citing a review as like the primary source and like, how many times does that slip through the cracks, especially in like veterinary research where you have to like track it down to figure out, oh, well, that review actually was cited this paper from 1970 and I actually can't find that paper. So how do I confirm that that's real and not just pulled
Right.
out from somewhere else from ChatGPT or wherever?
We should take a question from the chat, from Zoom, from the Zoom audience. Folks on Zoom.
Wait, I have one, I forgot.
Okay, great.
Besides cattle, how does the current research in AI cross between sheep, horses, goats, hogs, family pets, and poultry?
Wow. A one health question here, y'all.
So maybe not lame ducks, but I know there are people working on trying to use it for animal welfare audits, trying to say, okay, are the chickens in this barn, do they have appropriate welfare? Can they move enough? Those type of things. So that technology is being processed. I don't think anything is commercially available that I'm aware of, but that is being done. Like or even taking many different data sources. Like a lot of these facilities have like ventilation records, they have temperature records and all those things. So if you put all that data together and say, okay, how much are the, per se, birds eating or the pigs eating, they can say, okay, is this animal performing, but also does the welfare of it meet the standards that we want as an industry? So that's one example, but I'm not aware. I don't know if anybody else in the audience is aware, but I think they're all being developed, but nothing that I've seen out in live yet.
Manci?
I think at MinPro, we have this new research tool, and it's generating a lot of data. And so our goal is to, it's to detect chronic wasting disease in deer and other cervid like elk. So in this particular case, it's just how do we integrate AI with this huge amount of data that we have so that we can achieve this goal of One Health.
Right. So we're combining AI with tools that we've invented, right, to have an impact translationally. Roberta, Rob, right in the corner there.
So the New York Times is actually suing OpenAI
Yeah.
over, them accessing copyrighted material because New York Times sees its material as copyrighted. So do you think accessing data, obviously to have good AI, you need good data. Do you think accessing it in the future is going to be a problem? I mean, I personally can see different groups saying, no way.
Right. This gets at the heart of, data privacy, data management concerns. And
I was actually really interested when that story came out because we're working with the Associated Press and their data. And one of the things that was part of our contract negotiations is how do we prevent us from doing anything that would violate their exclusive arrangements with OpenAI? And so I don't think this is a fundamental AI question. I think this is a commercialization of information question. We all would understand that a human can read the New York Times, whether they pay for it or go to a library or anywhere else, and become educated. At the point in which they start coming back and saying, well, I can regurgitate things from the Times to you on my paid service where I'm an advice columnist or whatever I am, the Times has the right to come in and say, wait a minute, are you commercializing our content? Did you become educated or did you just copy my stuff and sell it to somebody else? And this is the follow-on to the wave of that happened with the news aggregator services, right? The Google News, Yahoo News, et cetera, that was, giving you the headline and a digest of the story and a ways to click through to the story. And the media were out there saying, wait a minute, you're charging or making money because you're placing ads next to this content. If you're going to do that, we want a cut of the revenue. And I think that that's something that there's a lot of momentum around solving. I don't think we're going to see a fundamental law change that would say that AI systems can't consume content that's available out there. But we are going to see this sort of massive question of how much do you have to credit revenue back?
right.
And will we end up with a system like we have for music and, okay, well, you pay a certain amount and it gets distributed among everybody that you consumed from, or is it something else? That I don't know. I think you talk to licensing and royalties people.
And,
But I think that the momentum in the world is going to be the information's there. It's going to be digested. How much do we have to filter the output to make sure it's not too close to the inputs that we've already learned?
kind of in a Napster moment now. I feel bad on this side of the audience. Did anyone have questions? Alonzo, do you have a question? Whitney?
Just very quickly, is there anything in the works or anything you know about using AI to basically mine the scientific literature to look for opportunities for research, hypothesis generation, for example, or anything in that regard, especially now with more and more open access papers and manuscripts out there? That would save me a lot of time for sure.
Yeah, that's a great question. Leveraging AI to find gaps of knowledge.
I think shortly, someone probably needs to build it because I personally try to ask ChatGPT a question and see if I can get some sort of reviews or important information back, but it doesn't really do a good job, at least generic one. So I still have to go back to PubMed and see the advanced search.
So if it doesn't have the data, it doesn't know it's, right?
There are a number of programs that have that comb through the paper databases and put together like networks of related papers by author, by topic, by subjects. You can start building like subsets of well, I need to know about this topic, at least get like some type of core set of papers related to that, and maybe some information, like summarize them and can give you some pretty good information. But
Yeah, I mean, the thing that would be easy to do today would be to digest a set of papers in a field and look at what they all suggest as future work and identify commonalities. The thing that will be very hard for AI systems to do without a deeper form of knowledge than they have today is to identify, hey, wait a minute, all of this work left a hole. Because right now, the system's building the model based on what's there. It doesn't know that that's a hole because it doesn't have enough prior context. There are people working on new bases for AI that are not the neural, let's try to think like people think model, but that come out of scientific principles first. And I think those have some hope of being able to identify gaps because they'll have a more structured model of what the space is and whether there's a hole in the space, but they haven't been applied to this problem yet, as far as I know.
Whitney?
So it's come up a couple times, training, right? We should have training for our grad students ourselves. I'm wondering what the thoughts are. What does that look like? How do we get it? How do we develop it?
Great question. This is academia, right? So how do we help the training the next? Manci, from your perspective as a
I think currently, as a graduate student, there are actually a lot of classes, online classes out there that gives you the very, very fundamentals of AI. Like what's the categories of AI? Like machine learning is AI, deep learning is also AI, but they function on very different perspectives. So I think from a graduate student level, maybe some of that can be incorporated into, first year general classes, or maybe there are recommendations to take graduate level classes from another college, because I know the AI classes already exist for students in computer science, but maybe have that toned down a little bit for
yeah.
Or actually, all of the courses online right now that I know of don't really talk about how AI is used in biology. It's like we use PCA, we use base calling, but like I didn't really know that there were AIs until like I really looked into it. So like the fundamentals about AI that's already used in research and how we can, use that in the future, maybe in a biology background would be helpful for me.
Opportunity for a new course. Taught by Gerard.
Oh. Yeah, I don't know. I think the course perspective is kind of unique, but then I do know that our graduate school here offers like using AI in your research and like using AI as a graduate student kind of thing for like professional development. So it's kind of some training there. And then I guess I guess it would kind of be hard to actually like have a professional development course or a class that like tells you like which ones to actually use, because the new ones coming out like all the time and like all these new upgrades, and like some are bad, some have opinions on them. So I guess it's going to be biased by like whoever's like teaching the class, like what do they use, what are they familiar with, so then they give you this recommendation, but then someone might disagree, someone might have had a bad time. So I think training someone to use AI is going to be difficult, but I think depending on like what you're actually using it for is like the key there.
So it feels like it's the Wild West right now, and you know, we go through these major technological revolutions, and for me, it was, you know, going through next generation sequencing. I felt as a graduate student, I felt like, and we didn't have next generation sequencing technologies where I was like, there's no way I'm gonna get a job. I need to learn how to use this technology to survive. So that led to the career path that I chose, to get that experience. I believe that this is the same moment for AI. Like we need to learn, our students need to learn how to use it and leverage it in order to get ahead, because if they don't, they're gonna be behind. So with that, we have, we're running out of time, actually. So please, everyone, thank you. So join me in thanking the panel for their time today. That was a fantastic discussion. This is great. We have one final announcement from Kevin.
So could everybody just join me in thanking the research office team? So Adrian, Jessica,
Yep.
and Shannon. Stuff like this takes a lot of work, guys, and we have been working. I've been working a little bit. They've been working a lot. So please.
Great work.
Okay, as you can see, we have a lineup of speakers for the next few of our RIDE seminar events. So I hope to see you all the second Wednesday of every month at noon. For the near future, it's going to be in this room. Scheduling meeting places is not easy in the far future, but keep an eye out for messages from the research office on where the seminars are going to take place. If you are internal to the U of M and you want to talk about your science, please get into contact with me. If you're hosting a visiting scientist for some purpose, maybe you're a collaborator from a different institution and you think that it would be a service to the rest of the CVM community to have them give a seminar, please get into contact with me. We would love to collaborate. So thank you all for being here, and hope to see you next time.